Hey y'all, welcome back. So it's been a little while since I finished recording and posting videos going over all of the problems on the official College Board study guide for the CLEP College Algebra exam. And since then, I've had many students and even some people on YouTube post that they were able to take and pass the test, and I've gotten a ton of feedback about what kinds of questions are actually on the test versus what was on the study guide. So in this video, I'm going to go through a compilation of problems that I've put together here that I think will more closely represent what you can expect to see on the test. Now, of course, there's no guarantee that any of these problems are going to be on the test. In fact, as we go through these, you'll see that there's quite a few of these are not going to be similar to ones that you see on the study guide. Now, the good news is all of the concepts that are tested on this CLEP test are still pretty much the same. So you're still expected to know the same key concepts that we've gone over, even going back a few years. So what I thought we should do here is kind of go through these newer problems, talk about how they might be different than what you see on the study guide, what concepts might be more emphasized. But again, there's no guarantee that you're going to see these kinds of problems. And the way that standardized testing is going nowadays is moving towards a adaptive style of a test so that the questions change depending on how well you're doing throughout the test. I'm not 100% sure if this test is quite like that yet. I'll look back into that and maybe put a little update in the comments, or if someone knows better than I do, maybe you can comment below and give us a clear answer on that. But either way, it's probably going to turn out to be like that in the future anyway. So don't expect that you'll see these exact same problems, but we are going to go over some concepts that you will definitely need to know for the test. So I've got a collection of problems here, 56 problems, and I'm going to try to work these like I was going through the test. So I already did a deep dive into a lot of different problems on strategies that you can use to solve different types of problems, but today I'm just going to sort of narrate my thought process as I work through these problems and kind of take it like a mock test. So my goal here is to complete all these problems, all 56 of them, within 90 minutes, which is how long you will get for the test. So we'll see if we can do that. Not 100% sure we can, because sometimes as I'm explaining, it just takes a little bit longer than if you were just, working the problem in your own head. But I think it might be doable. So let's go ahead and get started, and we'll start here with number 1, which says, what is the greatest common factor of the 3 terms in the polynomial? So on the study guide, there was one problem, the very last problem on that study guide, number 88, where you do have to factor a greatest common factor, but the question's worded so that you have to not only factor but write the factored form. In this problem, it's actually a little bit easier because you don't have to write the full product. All you have to do is come up with the greatest common factor. A lot of times, this greatest common factor here is known as the GCF. Okay, so if I say GCF, I'm talking about greatest common factor. What we want to do is look at these 3 terms, and these are the 3 terms right here, and try to come up with what term can divide each of these terms evenly. The strategy I like to take here is to first look at the leading coefficients and see if we can come up with the largest number that all of these are divisible by. Now, 12 is the smallest number, so the number can't be any bigger than 12. So I'll start thinking about that, but 12 doesn't divide 18, so that's not going to work. So I'll move downward in my factors of 12. The next largest factor of 12 would be 6. And so I'm looking at these numbers and hey, yeah, I can divide 6 out of each one of these. So 6 is going to be part of my GCF. Now I'm going to look at my x's. Okay, I've got x to the 4th, x squared, and x cubed. And the GCF will be the fewest number of x's that appear in any of these terms. So if I've got x to the 4th, x squared, and x cubed, the x part of my GCF is going to be x squared, because this is the one that has the smallest exponent. And the reason why that's the GCF is because we can divide out 2 x's out of each of these terms. You can't divide 3 because this term right here only has 2 x's to sort of take away. So x squared is going to be part of the GCF. And then we're going to look at the y's. We've got y squared, y to the 4th, and y. And so we'll do the same thing that we did with the x's and basically just divide out the most number of y's that we can. With the first term, you have 2 y's. The second term, you have 4 y's. The last term, you only have a single y. So the most number of y's that you'd be able to divide out of all the terms would just be y. And so this would be our solution. 6x squared y, which we can see is choice D here. And that's number 1. So yeah, there wasn't one that was like exactly like that on the study guide, but that very last problem 88 is pretty similar. So let's take a look at number 2. Number 2 says if 2 to the power of x times 2 to the power of y equals 8, then what is the value of x plus y? Now, there were a couple problems on the study guide that require you to know your exponent properties pretty good, but there weren't a ton of them. And what I'm kind of noticing going through these problems and just after hearing feedback from people who have taken the test is that there's a little bit of a larger emphasis on exponent properties than you might suspect having worked through the study guide. So make sure that you are on top of your exponent properties. And so the one that we're going to use here is the power of products property. And basically what this says is that if you multiply 2 powers that have the same base and you want to combine them, then you add the exponents. So a to the x times a to the y would be like a to the x plus y. And so this property is what we're going to use to solve this problem. So if we have 2 to the x times 2 to the y equals 8, we could rewrite that using that product property as 2 to the x plus y. Then, if you know that 8 is a power of 2, in fact it's 2 cubed, we can rewrite 8 as 2 cubed. Now, looking at this equation, it's probably pretty obvious what the answer is going to be at this point. We have 2 to the power of x plus y and 2 to the power of 3, and those are equal, and what this question is asking for is the value of x plus y. And so I think it is a little obvious what the answer is going to be here, but just in case you're still a little confused, what we're going to use is something called the one-to-one property, which basically says if you've got 2 powers with the same base and they're equal, so like 2 to the a equals 2 to the b, if you have that set up, then you can say that a equals b. Yeah, so in this case, we can say that x plus y equals 3. And that's going to be our answer, which you see over here is letter G. Okay, there's number 2. Let's look at number 3. Which of the following is equivalent to the natural log of the square root of x divided by y cubed? Now, just like with the exponent properties, there were some problems that require you to know your logarithm properties. Like for instance, if you look back at problem number 55 on the study guide, that's going to be probably the closest you're going to get to a problem like this. But the big difference between that problem, the one on the study guide, and this one is that the one on the study guide requires you to condense logarithms to kind of simplify and bring them together and write the expression as a single logarithm, whereas this one's wanting you to expand it. So you're going to use the same kind of properties, but just kind of in the different direction. So we'll start here with the expression natural log of the square root of x over y cubed. And we can use the quotient property. And basically what the quotient property says is if you have any logarithm of a quotient, so like a over b, we can split that up and write that as log of the numerator minus log of the denominator. And so that's what we're going to do here. We have log with a base of Euler's number, which is how we write, which we write as natural log, or ln. And so we can use this property and we can rewrite this as the natural log of root x minus the natural log of y cubed. And if you look at your answer choices, you see none of them really look like that. And that's okay, we're not quite done yet. We're going to use another property, and that is that when you have a power in your logarithm, so if you have like log of x to really any power, you can rewrite this using something called the power property as a times log of x. So in other words, if the argument inside the logarithm has an exponent, you can rewrite that as a coefficient rather than an exponent. Pretty nice. I don't think that's super obvious at first. So we're going to use that power property. There's one other thing that we need to know here, and this comes up later too, and that is anytime you are taking the square root of a number or a term, that's equivalent to raising that base to the 1/2 power. So we can rewrite this square root of x as x to the 1/2, and then we can use this power property. So rewriting both of these logarithms using that power property, we get 1/2 times the natural log of x minus 3 times the natural log of y. And yeah, that should be our answer. Let me go see if I can find it. Yeah, so sure enough, here it is, letter M. Okay, that's number 3. So number 4 says, which of the following is a factor of 36x squared minus 16y squared? And so what we have here is something called a difference of two squares. That's a setup where we have something squared minus something else squared. And we can factor this as a plus b times a minus b. Now, there was a problem that's kind of similar to this on the study guide. It was number 2. But this one I think is actually easier than what you see on that study guide. In this case, my a would be 6x, and my b would be 4y. Basically what we're looking for is the square root of each of those terms. And so if I want to factor 36x squared minus 16y squared, I'll write that down here. I can use that difference of two squares trick, and I forgot an x on that. Let's fix that. And write this as 6x plus 4y times 6x minus 4y. This problem is just asking for one of the factors, so you're really looking for either one of those, and we see that we have one right here, letter B. And so that's number 4. Number 5 says, for all y values greater than 0, which of the following is equivalent to, and then we've got this expression right here. Already we're seeing another exponent property question. Yeah, so you really got to know your exponent properties pretty good. So let me walk you through this one. First, I've got this power of 4 on the outside, and anytime you're raising a power to a power like that, you need to make sure to apply that exponent to every factor that's in the parentheses, and if any of those factors has an exponent already, then you multiply those exponents. So the power to a power property says that if you are raising a power to another power, you multiply the exponents. But we'll get to that in a minute. First, let's just apply that power of 4 to each term inside the parentheses. So this would be like 2 to the 4th, y cubed to the 4th, and then y to the 1/4 to the 4th. Next, we'll use that power to a power property and simplify some of this. Now, 2 to the 4th, we can evaluate that, and if you're not sure what 2 to the 4th is, you can always just use a calculator real quick to type that in. 2 times 2 is 4, times 2 is 8, times 2 is 16, so 2 to the 4th is 16. Y cubed to the 4th would be y to the power of 3 times 4, because of that power to the power property, so we get y to the 12th. And then same thing on the denominator. We're going to use that power to a power property again. And so 1/4 times 4 would just be 1, and so we get y here. The last thing to do is to simplify the y's here. We've got y to the 12th divided by y. That means that we've got 12 y's being multiplied in the numerator and just a single one in the denominator. So one of those pairs of y's will reduce to 1 or cancel out. I'm not going to write 12 y's right here, but let's just know that one of them will cancel out, and so that'll make this 11, and then that will reduce to 1 also. So our final answer here is 16 y to the 11th. There is another property that might help you here, and that is whenever you divide powers with the same base, you can subtract the exponent. So 12 minus 1, you still get that 11. All right, let's see, where's my solution there? 16, oh, there it is. Letter E, we got it. Let's move on to number 6. Number 6 says, if A is equal to B divided by the absolute value of B and B is less than 0, then which of the following must be true? There really wasn't too much on the study guide regarding absolute value, and really there's no questions like this one. So we're just going to kind of start from scratch and I'll walk you through it. So it says A is B divided by absolute value of B, and B is less than 0. This is kind of our key piece of information here, and what this means is that B is negative. So what I'm going to do is kind of go through and see, okay, if you take the absolute value here of B, so we've got A equals some number, and then divided by the absolute value of B. So absolute value is a function that outputs the positive version of whatever you put in there. What it really does is measures the positive distance that that number is away from 0. So if B is negative, like let's say B was like negative 5, the absolute value of negative 5 is positive 5, because negative 5 is 5 units away from 0. So that means that this absolute value of a negative number is going to output the positive version of this number, which is the opposite of what it started as. So the only reason it's the opposite is because B is negative. If B was positive, then it would just be B. Now we can see how this would simplify. B divided by B is 1, so we get negative 1. Answer is E. Number 7, we get this huge fraction problem, and there's actually one that is extremely similar to this on the study guide, and it was number 5. So the way to solve this, first, we're going to rewrite this division, fraction division problem, if you will, as a multiplication problem. So times x minus 5 to x squared minus 4. The way to do that is division is defined as multiplication of the reciprocal. And so the reciprocal means basically you just flip this little fraction here. And so notice I put x minus 5 on the top, x squared minus 4 on the bottom. That's all you have to do to change this to a multiplication problem. Now before I go and start multiplying this, what I'm going to do is factor what I can. And the only thing you can really factor here is this x squared minus 4, which if you look at it, you can see is kind of like what we had up here on this fourth problem. It's a difference of 2 squares. So the square root of x squared is just x, and the square root of 4 is 2. So we can rewrite that second denominator as x plus 2 times x minus 2. All right, so now when you multiply fractions, you don't have to find a common denominator or anything. You just multiply straight across. So I get x plus 2 times x minus 5 over x squared plus 25 times x plus 2 times x minus 2. Now notice how you have x plus 2 both in the numerator and the denominator, so those will reduce to 1. And then whatever we have left over, that's our solution here. So that's going to be letter D. Number 8, we've got the area in square feet of a rectangular parking lot is represented by the expression x cubed plus 27. So I'm going to draw a rectangle here. The area is x cubed plus 27. Let x plus 3 represent the length in feet of the parking lot. Which expression represents the width in feet of the parking lot? So One thing you could do here is you could recognize that x cubed plus 27 is a sum of cubes, and there is a little formula to help you figure out what the factors are there. But I think this might be easier than trying to memorize that formula. There's an easier way to do this. And that is to actually construct this rectangle and kind of divvy it up into a 2x3 box here, where we know that the leading term, or the product, has to be x cubed, and the last term has to be 27. So what I want you to think about is, like, what would we have to multiply by x plus 3 so that the result is x cubed plus 27? The area of a rectangle is the length times the width. So it's going to be this x plus 3 times whatever the width is. So let's think about what the width would have to be. Like, for instance, if the first term of the area is x cubed, then in order to get that x cubed, I'd have to multiply x by x squared, right? X times x squared is x cubed. Similarly, to get this 27, I would need to multiply 3 by 9 to get 27. So we've got basically two of the three terms already figured out, right? X squared and 9, x squared and 9. We know it's going to be a or b. We either going to have plus or minus 3 right here, and that's going to be our answer. So let me kind of walk you through how you would get that, even if you didn't have the answer choices. As we fill in these little squares here, what we're doing is, this is actually called something called the box method, where we multiply each row by each column. So like x squared times 3 is going to be 3x squared. Our area has no x squared terms, so somehow we have to cancel that out. We got to get rid of that 3x squared. And so to do that, we need to multiply x by negative 3x. Negative 3x times x is negative 3x squared. So that when I combine those like terms, these two like terms will cancel out. And that's kind of what you want to happen. Now, I'm pretty sure we've got our answer right now, which is A, because that does have to be negative 3x. But just to verify, I'm going to fill in these other two boxes and cross my fingers and hope that everything cancels out. So negative 3x times 3 would be negative 9x, and 9 times x is 9x, and sure enough, those two do cancel each other out. They add up to 0. So there's our answer, x squared minus 3x plus 9. Number 9 says, if y is less than x is less than 0, which of the following number is greatest? We got another absolute value problem. Like we saw earlier in this video, this absolute value seems to be showing up a little bit more often than I would have expected, but that's okay, we can still answer this. And with a problem like this one's very kind of abstract and conceptual. I think the best way to go about doing this is actually to just pick any value for x and y that will meet the initial conditions, and then see which of your answer choices is the biggest one. So like if y is less than x, which is less than 0, I'm just going to pick some easy numbers to work with. Like I'll pick x to be negative 1 and y to be negative 2. So which of the following numbers is greatest? A, 0. Okay, so that gives us something to work with. So x plus y would be negative 1 plus negative 2 is negative 3. The absolute value of x, which is negative 1, so absolute value of negative 1 is 1. The absolute value of negative 2 is 2. And the absolute value of, let's see here, negative 2 minus negative 1 would be like negative 2 plus 1. So the absolute value of negative 1 is also 1. So the largest number here is going to be 2. And that's it. You can kind of work this a little differently, but I think it's a little bit more complicated. You start getting into cases and stuff. I think just picking a number for x and y to test will make this problem go by a lot faster, and you can even use that strategy on a lot of different problems. Number 10, no words here. There's really nothing like this. I looked around on that study guide. I couldn't find one that was even close to this one. So we're going to solve this one kind of like we did the sum of cubes problem. Okay, where basically we set up this multiplication and try to fill out all the gaps as we go. So we know what our final answer should be. x cubed plus 4x squared minus 3x minus 2. We're dividing that by x minus 1, and we want to know what the quotient is. But whatever the quotient is, it needs to be able to multiply by x minus 1 to get, back to the numerator. In other words, like if you have 10 divided by 2, which equals 5, then what must be true is that 5 times 2 is 10, which obviously is true. So, in other words, our answer times x minus 1 is going to give us the numerator. So let's start setting this up, same way we set up that other problem. Where we want to find x minus 1 times something gives us this x cubed, or this cubic expression. So let's start with the first term, x cubed. And ask yourself, what do I need to multiply by x to get x cubed? Well, I need to multiply that by x squared. X squared times x is x cubed. And then I'll look at the last term, and we'll kind of like work our way in. The last term is negative 2. So what do I need to multiply negative 1 by to get negative 2? I need to multiply that by 2. So right away, we can sort of narrow down our answer choices. They all have x squared, so that's not really helpful. But the fact that the last term is plus 2, it allows us to eliminate some of our choices here. So to find the middle term, we just need to kind of logically work inward. So x squared times negative 1 is negative x squared. But we want our middle term to be 4x squared. So in order for this to be 4x squared, I need something that will add to negative x squared to give me that. And that's going to be 5x squared. 5x squared minus 1x squared is 4x squared. So in order for this to be 5x squared, I need to multiply x by 5x. Now I think we've got our answer here. It is going to be e. But just to make sure that we don't get anything else and everything else cancels out, we've got 5x times negative 1, which is going to be negative 5x. 2 times x is going to be 2x. And you can see that 2x minus 5x is in fact negative 3x. So we're in business. And our answer is definitely E. Number 11 says, if x and y are positive, which of the following is equivalent? Okay, so look, again, another exponent problem. Just more exponential properties just all over the place. Really noticing this is coming up a lot, so make sure you guys know your exponent properties. So I'm going to rewrite this a little bit. 4x times 1/2 times 9y to the power of 3/2. Just kind of cleaning this up a little bit. So first I'm going to apply this power of 1/2 to this monomial. Remember back at the beginning, I think was it the first problem? Let me scroll up a little bit. I think it was the first problem. Yeah, here we go. Not sure why everything else isn't loading up, but we said that the square root of x was equal to x to the 1/2. So anytime you are raising something to the 1/2 power, that is going to be equivalent to taking the square root of it. I'm not sure what happened to all the text here. And basically the reason I was going back to that is to show you that, hey, if we've got something to the 1/2 power, that just means that we are taking the square root of it. So the square root of 4 is 2, and the square root of x is just the square root of x. Now we can do something kind of similar here, but we do have this cubic on here. So we've got times 9. Now notice here, and I think this is where a lot of people are going to get this wrong, that this 3/2 is only on the y, it's not on the 9. That's different than this other one, because this other one has another extra set of parentheses around the 4x, so the 1/2 has to be applied to both the 4 and the x. On this one, it's only applied to the y. So we've got 9 times the square root of y cubed. Okay, well, we're just multiplying a bunch of things here, so we're going to combine what we can. 2 times 9 is going to be 18, and the square root of x times the square root of y is going to be the square root of x times y cubed. And so there's our answer. It is C. Let's move on to number 12. All right, number 12 says where to find which of the following is equivalent to this expression. And this is going to require that we do a little bit of factoring. We've already talked about the difference of two squares on two other problems here. Again, this is the third time it comes up, so make sure you know your difference of two squares, along with understanding absolute value and those exponent properties. So the numerator is going to factor as 2 plus 5x times 2 minus 5x. And that denominator, if you're not sure how that's going to factor, we can do, again, kind of like we've been using that box method before. We know that the first term is 5x squared, and we know that the last term is negative 6. So we have to come up with some factors that will multiply to this. So like 5x squared, since 5's prime, really the only two combinations of terms that are going to multiply this is going to be 5x and x. And then we need two terms that multiply to give me 6, where the two middle boxes, again, have to add up to that negative 13. So I'm just going to try something and see if it works. Like I'll try maybe 2 minus 3, and it looks like that's actually a pretty good guess there, because I think that actually is going to work. I got kind of lucky there. It might take you a couple guesses to get there. Usually it takes me like 2 or 3 before I actually settle on it, but I got lucky here. 2 times x is 2x. And so you see that negative 15x plus 2x is that negative 13x. That's how you know you did it right. And so that means our two factors here are going to be 5x plus 2 and x minus 3. So now we're looking at that fraction, and we see that we have the same factor in the numerator and the denominator. It doesn't look exactly the same. We've got 2 plus 5x versus 5x plus 2. But since addition is commutative, they are the same thing. And what that means to be commutative is that the order of the addition doesn't matter. Like 4 plus 6 is the same as 6 plus 4. So 2 plus 5x is the same as 5x plus 2. So anytime you divide anything by itself, it reduces to 1. So these will basically cancel out, leaving you with 2 minus 5x over x minus 3. That should be our answer if I can find it. And yep, it is A. Number 13 says if x is not 0, which of the following expressions is equivalent? And then we've got this big fraction with, again, exponents. My goodness, I'm kind of getting tired of these exponent property problems, to be honest with you. I mean, we're not even like halfway done, and a bunch of these require you to know your exponent properties. So I guess what I'll say is just, again, I've said this a couple times, make sure you know your exponent properties. I can't really emphasize that enough. Okay, so let's see. I'm just going to rewrite this, kind of clean this up a little bit. Okay, so the first thing I see is that we've got a negative exponent on there. That's something we haven't encountered yet, but anytime you have a negative power, that just basically means you want to divide that one by that term that many times, as opposed to multiplying by that term that many times. And so to get rid of that negative power, because that does kind of complicate things, we can rewrite that as a positive power of 5 if we move it up to the numerator. So we can rewrite this as x to the 7th times 2x squared to the positive 5th power over 8. Okay, so the next thing that we want to do is use the power to a power property, or product to a power property. Really, we're going to use both. We do need to apply this power of 5 to both 2 and to x squared. So I've got x to the 7th times 2 to the 5th times x squared to the 5th all over 8. Simplifying this a little bit more, we've got x squared to the 5th. That's going to be x to the 10th. Remember, when you raise a power to a power, you multiply the powers. And I'm also going to simplify this 2 to the 5th. So, I don't have all these powers memorized. I just kind of in my head multiply by 2. So 2, 4, 8, 16, 32. 2 to the 5th is 32. So x to the 7th times 32 times x to the 10th all over 8. We can reduce this 32 to over 8. 32 divided by 8 is 4. And then to combine our x's, since we're multiplying two powers that have the same base, we want to add those exponents together. And so that'll be x to the 17th power. So our answer is A. Number 14. Now there was one on the study guide. I know we've seen quite a few here that really don't correlate very well to the study guide. But this one, there is one on the study guide that's almost exactly like this one. It's just like number 6 on the study guide. but it's actually a little bit easier because the leading coefficient is going to be 1, so the factoring won't be as painful. To solve this, what I'm going to do first is multiply these two together using the distributive property. So x times x is x squared, x times negative 2 is negative 2x, negative 3 times x is negative 3x, and then negative 3 times negative 2 is positive 6. Then I'm going to combine my like terms. So I've got x squared minus 5x. And then here, with these constants, I do need this to be equal to 0 to solve it. So I'm going to subtract 2 from both sides and write this as plus 4 equals 0. Lastly, I need to factor this. This one's pretty easy to factor because the leading coefficient is 1. So if I set up my little box here, and I know I need the first term to be x and the second term to be 4, but I need two terms to add up to be negative 5, so that tells me that the two numbers that multiply to give me 4 have to be negative if they're going to add up to a negative. And really the only possibility there is going to be negative 4 and negative 1 to give me that negative 5x that I need. So I've got x minus 4 times x minus 1. Using the zero product property, we can set each one of these factors equal to 0. And then solve them independently. So we'll add 4 to both sides, add 1 to both sides, and there we go. We have our two solutions, 4 and 1, which we see in letter C. All right, number 15 says, what are the solutions of the equation 2x plus 5 equals the absolute value of 3x? So I'm not going to get into the nitty-gritty details here as far as like how you would solve this normally, because this, when you break it down, is just a solve for x kind of equation. And when you're working through the test, if you ever get a solve for x kind of question, whether it's quadratic, logarithmic, absolute value in this case, the easiest way to get these questions right is just to plug in the answer choices and take advantage of the fact that it is multiple choice. So that's what I'm going to do here. So first I'll test -1 and see if that works. And so basically what I'm going to do here is plug in -1 for everywhere where I see x. So 2 times -1 plus 5, and I want to know, does that actually equal the absolute value of 3 times -1? So trying to evaluate this, you could throw it in your calculator, but this one's, the numbers are pretty small, so we could probably handle doing it in our head. 2 times -1 is -2, plus 5 is -3, so we have the absolute value of positive 3. Does that equal the absolute value of -3? And in fact it does. The absolute value symbol, or that function rather, all that does is change whatever number is on the inside to be positive. So if it's negative, it changes it to be positive, so this absolute value of -3 becomes 3. And then the absolute value of positive 3, since it's already positive, nothing changes. And so yeah, 3 does equal 3. That means -1 is a solution. Now, don't be too quick to answer A here. We know it can't be B or C or E because -1 is a solution, but 5 might also be a solution. So let's go ahead and test that one as well. And so here we've got 2 times 5 plus 5, and we want to know, is the absolute value of that equal to the absolute value of 3 times 5? We've got 2 times 5 plus 5 would be, let's see, 10 plus 5 is 15. The absolute value of 15, does that equal the absolute value of 3 times 5, 15? And sure enough, yeah, the absolute value of 15 should equal itself. So that means 5 is a solution, and so we got D. Notice here, we didn't really have to know exactly how to solve the equation to get this one right, and I encourage you to do this on every single solve for x problem you see. Don't worry about, using quadratic formula, for instance, if it's a quadratic. Just throw the answer choices in and see which one works, and you'll be more likely to get it right that way. Okay, let's move on to number 16. It says, what is the slope of the line in the xy plane given by this equation? So ultimately what we have to do here is find the slope. And so to find the slope on number 16, you just have to be a little familiar with slope. Where does slope come from? How do you get it in the equation? And on the practice test, there really wasn't anything asking for slope directly. But basically what we want to do here is we want to put the equation into y equals mx plus b form. So that way we can identify the slope, which is going to be the m. So we just need to modify this equation, manipulate it algebraically using our properties of equality. So I'll start by subtracting 40 from both sides to get 18y minus 3x equals negative 40. I want us to leave y over on the left-hand side, so what I actually want to do here is add 3x to both sides. $18y equals 3x minus 40, and then finally we want to divide both sides by 18. I'm running out of space here, but I'm going to try to squeeze it in. So divide both sides by 18, and we get y equals 3/18, that does reduce, so I'll come back to that, x minus 40 over 18. So this is our equation, y equals mx plus b, our slope-intercept form. Our slope is going to be that m value, or the coefficient to x, which is this 3/18. Now we don't see that explicitly as one of our answer choices here, but 3/18, if we divide both 3 and 18 by 3 and reduce that fraction, we do get 1/6. So our answer here is C. Number 17. It says a store has 156 packages of batteries in stock. Each package contains either 4 batteries or 8 batteries. The 156 packages contain a total of 1,048 batteries. How many packages that contain 8 batteries does the store have in stock? So first, let's declare our variables. We can let x be the number of, I'll just say 4 packs, and y is the number of 8 packs. And so we're going to write 2 equations, one that has to do with how many packages there are total, and one that has to do with how many batteries there are. So as far as how many total packages there are, we have the total number of 4 packs plus the total number of 8 packs is a total of 156 total packages. And then the next piece of information tells us about how many batteries there are. If there are 1,048 batteries, and we have 4 batteries in every 4 pack, and 8 batteries in every 8 pack, the total number of batteries is 1,048. So here's our system of equations, and we have to solve this. You can use a variety of methods if you're going to solve this directly, substitution, elimination, but let me show you an alternate way on how you might approach this. What we could do is just take the numbers that are given and test them and see if they actually work. So here's how I'll do that. They'll say, so what we're trying to solve for is how many 8 packs do we have, how many packages that have 8 packs. So we're going to plug these values into y, see what x would have to be, and if we get the same x value in both equations, then we know we're doing it right. So these are our y values here. So we'll start with just 82 and we'll work our way down. So 82, we're going to plug that in to y and solve for x. We'll start with the first equation. X plus 82 is 156. So if there's 82 packages of 8 packs, 156 minus 82 means there's 74 4 packs. If that's true, then we should be able to plug those 2 numbers for x and y into the second equation. So let's test that out. 4 times 74 plus 8 times our y value 82, and we want to know, is that 1,048? So let's just test this out. 4 times 74 plus 8 times 82, and we get 952. So not quite, right? So that means that A can't be our right answer, but we're pretty close. So if I had to guess, I'm guessing it's going to be either B or C, but let's find out. So I'm going to test B, and I'm going to change this 82 to an 86. If I do that, then 156 minus 86 is going to give me 70 packages of the 4 packs. And so now I'll test these 2 numbers into the equation. I'm going to replace 74 and 82 with 70 and 86 and see if this one works. So 4 times 70 plus 8 times 86 is 968, so we're still not quite there. Yeah, let's do the next one. So we'll try 94. We'll plug that into y. So if y is 94, 156 minus 94
is 62. Okay, so we could plug that in for x, plug in 94 for y. Use our trusty calculator here. 4 times 62 plus 8 times 94, and we get 1,000. Not quite there. I had a feeling about that D. I think that's going to be our correct answer, but let's see. So yeah, that one didn't work, unfortunately. So let's clear that out. And we're going to do this one more time. But this time, well, hopefully one more time. If 98 doesn't work, then we're going to have to do it again. That would just be our luck, right? It would be the last answer we try. So 156 minus 98 gives us 58 for our x value. So what we're going to test here is 4 times 58 plus 8 times 98. And fingers crossed this is 1048. Really hope it is. So I'm ready to move on to the next problem here. Oh, you got to be kidding me. It's 1016. All right, so you might be tempted to just go ahead and answer E here because, process of elimination says it's got to be E. But let's test it just in case. Just in case. I thought it was going to be D, but I guess we have to go a little further here. If y is 106, then that means x has got to be 50. I can do that subtraction in my head. So 4 times 50 plus 8 times 106. Oh, come on. I really want this one to be right, because if it's not, then we did something wrong. We got to go back and fix it. And sure enough, this is 1048. That's what we were looking for. Sometimes you get lucky, and the first number you try is correct. We saw in the last problem that we got to see. Oh, no. Which one was it? Number 15. Yeah, we were able to get at least halfway there just with the first answer choice. So sometimes you get lucky, and sometimes, like with this number 17, it's just the last answer choice that's there. But anyway, yeah. So the answer here is E. Number 18 says, which of the following is one of the roots of the equation? Okay, so for number 18. We could solve this with quadratic formula, or we could solve it by factoring, but this is, once again, another one of these solve for x problems, and you should expect a few of these, and you should get them all right, because you don't have to actually know how to solve it. We don't need to necessarily memorize the quadratic formula here, or remember the factoring process. It's good to know those things, like in case you get like a fill-in-the-blank question. There's very few of those. Most of them will be multiple choice. So we're just going to test these answer choices out like we did in the last couple of problems. And hopefully we don't have to go all the way to E to get our answer, but let's try it out. So we'll try choice A, 15 times negative 2/3 squared plus negative 2/3 minus 2. And we really want that to be 0, but it may not be. Make sure when you're doing this arithmetic, you see me using a calculator here. There's no reason to try to do this by hand and risk getting it wrong. It'll probably take you longer to do it by hand anyway, and you'll be more likely to make an error. So, take advantage of the fact that you do get a calculator on here. Okay, so this one equals 4. That's not what we're looking for. So we're going to go on to the next one. We want it to be equal to 0. Okay, so next up, we'll plug in negative 2/5. See what that thing equals. And look at there, we got 0. So our answer B. If you have extra time on the test, like if you finish all the questions and you have a little bit extra time on these where we're checking, item by item, at this point I would just move on. But if you have time at the end of the test and you still have, a little bit of time left, go back and make sure that none of the other answer choices work. Because you don't want to accidentally mistype it and you think you got the right answer, but really it was D. And if you check that, you'd be able to catch that. Just for the sake of time, I'm going to skip that for this. But if you have extra time, go back and check those other answer choices. Number 19 says a patient took 200 milligrams of an antibiotic in a single dose. At the end of each subsequent hour, the amount of antibiotic in the patient's body was 11% less than it was at the beginning of the hour. Approximately how many milligrams of antibiotic were in the patient's body 7 hours after the dose was taken? This is an exponential decay problem. It's kind of like number 81, but it's a little easier because the exponent is just going to be t for hours. On the practice test, you had to figure out what that exponent would be. It was like an expression in terms of t, but this one it should just be t. So let's go ahead and set this up as an exponential decay problem. The 200 milligrams is going to be our initial amount. So we'll say y equals 200 times. And then it says at the end of each hour, there was 11% less medication than was at the beginning of the hour. So you start off with 100%, that's 1, and then you subtract the 11%, so minus 0.11, and that will give you your multiplier, okay, or your decay rate. And then we'll say to the x power, where x is the number of hours, and we want to know how many milligrams were present after 7 hours. So all we need to do is plug in 7 in for x. I would just put that in your calculator. You really didn't even have to do this little arithmetic. I just thought I'd rewrite it a little bit to make it easier to read. But you're safe to go ahead and put 1 minus 0.11 in the calculator too. So anyway, I'm going to type all this in, hopefully get a good answer out of here. And I'm getting approximately 88.5, so our answer is C. So yeah, this one's a little bit more straightforward than what you saw on the practice test. Number 20 says, which of the following are solutions of the system of equations shown? Okay, so the system of equations is right here, and we need to find solutions. Another solve for x kind of equation. Now here you've got x and y, but you could still use the same process. And what I mean by that is like use your answer choices to your advantage, plug them in and see which one works. The one that's on the practice test that's kind of like this is, I don't recall which problem number it is, but there's one problem where you've got a circle and a line and you're trying to figure out what the solution is, but I don't think it's exactly like this. So either way, we're just going to be plugging in numbers, so I think we can get this right even without having like a great idea of what these graphs looks like or anything. This top one is a circle and the bottom one's a line, so you can kind of think it's like something like that. I don't know exactly what it'll look like. And that's not really important. The important part is that we figure out where the intersection points are. So let's start with the first one. And basically what we're going to do is plug these numbers into x and y, see which one works. So start with the first one. Negative 9 squared plus 3 squared. We want to know, does that equal 90? If it does equal 90, we need to check it with the second equation just to make sure it is a solution to the system and not just this one equation. If it doesn't equal 90, then we can move on. Say, this isn't just not going to work. So you get 9 squared plus 3 squared, and that does equal 90. So that means that negative 9 comma 3 is a point on the circle. So let's check and make sure that it's also on the line. So negative 9 plus 3 times 3. We want that to equal 0. And sure enough, negative 9 plus 9 is going to be 0. So that means negative 9 comma 3 is a point of intersection, but there might be another one. Remember, this is like a circle with a line through it, so it's likely that we're going to get 2 points of intersection. So we need to test. We know this is right, so anything that doesn't have negative 9 comma 3 has got to be wrong. So this is wrong. Okay, here we go. We got this could be right, and then this. So really, all we need to do here is test 9 negative 3. And see if that's a solution as well. I'm guessing it probably is, but let's just double check. So 9 squared plus, what is it, negative 3 squared? That'd be 81 and 9. That does equal 90, so that checks out. And then also we've got 9 plus 3 times negative 3, and that is also going to be 0. So 9 negative 3 checks out as well, so our answer is D. Hopefully you're noticing there's a lot of problems on here where you can just plug in the answer choices. And if you remember that strategy, that can get you a good bulk of the questions correct. All right, number 21 says, which of the following is the solution to the inequality? So we do need to solve this one. I know this is a solve for x, but it's not an equation, it's an inequality. You could still plug in numbers that are in the solution set back into the equation. But I feel like this one's probably going to be better off if we just solve it like we're supposed to. So let me walk you through the steps here. When you have an absolute value, whatever number is inside there changes to positive. So if the number was already positive, then nothing changes. But if it was negative, it changes to positive. So basically what happens here is either 8 minus x is going to be greater than 5, or the opposite of 8 minus x is going to be greater than 5. Because remember, like if I plug either of these numbers in, I'll output the same thing, whether it's positive or negative. So we do have to solve both of these individually. I'll start with the left one. We'll subtract 8 from both sides to get negative x is greater than negative 3. And then dividing both sides by negative 1 gives me x is less than positive 3. Another way of representing this solution set, x being less than 3, would be to say that x is all the values between negative infinity and 3. And the answer choices here are using that set notation form, so you will have to know how to rewrite this inequality using brackets and parentheses. Okay, so that's part of our answer. For the next one, we're going to distribute this negative and get negative 8 plus x is greater than 5. Then we'll add 8 to both sides. To get x is greater than 13. And yeah, that's it. So if x is a bigger number than 13, then we could say x can be any number between 13 and infinity. So here's our solution set. We're going to just basically box this. The little u in the middle stands for union, and that just basically means that any number in either set could be a solution. So yeah, our answer here is going to be E. Number 22 says consider the equation x squared minus a plus bx plus ab equals 0, where a and b are constants. Select two of the following choices and place them into the blanks so that the resulting statement is true. So this is not a multiple choice. I guess in a way it kind of is, but it really is considered a drag and drop problem where you have these different options that you can pull into the blanks. So the statement that we're trying to make true says if the constants a and b such that blank, then the equation has blank. So this has to do with the discriminant. Okay, and really this is more of a conceptual question to make sure you understand what the discriminant is. The discriminant, maybe I'll write this down, is normally b squared minus 4ac. It's that expression underneath the square root in the quadratic formula. But here we've got constants that are in terms of these parameters a and b, so I'm going to be careful about how I write this. You know, in general, it's b squared minus 4ac, but in this problem, the b here, which is this coefficient of x, is negative a plus b. All right, just keep that straight. And then the a is just 1, and then the c is this ab. So the discriminant in this case would be negative a plus b squared minus 4 times a, which is just 1, so multiplying by 1, I shouldn't have to write that, times c, which is ab. Okay, now it says that, so what we're trying to do is figure out, like, what does the discriminant tell you about the function? So the discriminant, if it's positive, so if the discriminant's positive, then there are two solutions. If the discriminant is negative, then there are no solutions. And I'm running out of space here, but if the discriminant is actually equal to 0, then you get one solution. So here's the expression for our discriminant. So in order for this to have no solutions, I would need this thing to be equal to 0. I don't know if that's actually possible, but let's see here. I'm going to simplify this. I'm going to actually square this out. Now, a negative times a negative is a positive, so this will be positive. And it'll be positive a plus b times itself. So a plus b times a plus b would be, well, it'd be a squared plus 2ab plus b squared. And we have this minus 4ab. I'm going to combine like terms to get a squared minus 2ab plus b squared. So we've got three options. Either a is less than b, greater than b, or equal to b. I think this will be easiest to simplify if we set them equal to each other and see what happens. So if a is the same as b, then we've got a squared, and I'll just change every b to a here since this is the one we're going to test first. 2 times a plus a squared. All right, so here we've got a squared plus a squared is 2a squared minus 2a squared, and that equals 0. So if a equals b, then the discriminant is 0, and that means we only have one solution. This is definitely one of the harder questions because it's very conceptual and you got to really understand what the discriminant is. So, don't feel too bad if this is one of the many questions that you don't get right. In order to pass this test, you don't have to get all the questions right. You just need to get about half of them. So if this one's sort of over your head, don't worry don't stress out about it. This one definitely is one of the harder problems. If you're looking for extra practice problems about the discriminant that are still a little conceptual, on the practice test, you might check out problems, what were they? 16 and 53. So go check on those problems if this one's giving you a hard time. Number 23 says, which of the following intervals is a solution set to this inequality? Okay, so this one we just need to solve an inequality. So let's go ahead and do that. So we've got x plus 3 divided by negative 2 minus 1 is greater than 5. I'll start by adding 1 to both sides. So that gives me x plus 3 over negative 2 is greater than 6. Multiplying both sides by negative 2 gives me negative 12 on this side. And remember, when you multiply or divide both sides of an inequality by negative, you do need to flip the inequality symbol. So after that, I will subtract 3 on both sides and get x is less than, what would that be, negative 15. Since what we're doing is we're trying to communicate that, hey, all the solutions are where x is less than 15. They're all of these answers. So the way to write that using these parentheses would be everything from negative infinity up to negative 15. So our answer is A. '24 says, to win a new car on a game show, a contestant must guess the price of a blender within $1.50. If the price of the blender is $60 and the contestant's guess is X dollars, which of the following inequality specifies the values for X for which the contestant will not win the new car? So in order to win this car, you have to guess the price of the blender, which costs $60, and you have to guess within $1.50 of that. Your guess, which is X, if that has a difference of $1.50 between it and $60, then you win. So in other words, like if you subtract $60 from your guess and you take the absolute value of that to make sure that the difference is positive, this expression right here, this x minus 60, would have to be smaller than $1.50 in order for you to win. So in order for you to not win, that difference has to be bigger than $1.50. So if it's smaller than $1.50, then you win. But if the difference is bigger than $1.50, then you don't win. So our answer here is C. There's really no work to show for this problem. You just have to be able to interpret the word problem and set up an equation to model it. So yeah, it's going to be C here. Number 25 says, which of the following is the solution set of this inequality? So we're going to have to solve this inequality, and solving a quadratic inequality is no easy task, so just buckle up. This one's kind of tough. If you're looking for kind of a similar problem, you can work out number 6, but number 6 on that practice test is not an inequality, it's an equation. So this has an extra layer of complexity to it. So I'll just work this out the way that we worked out number 6. First, I need to multiply these out. Okay, so I'm going to use the distributive property and distribute 2x to 3x. It's going to give me 6x squared. 2x times negative 1 is minus 2x. Negative 1 times 3x is going to be minus 3x. And then we have negative 1 times negative 1 is plus 1. And then I'm also going to subtract 7 from both sides and move that 7 over so that I have a 0 isolated on the right-hand side. Now at this point, we want to combine like terms. So I get 6x squared minus 5x minus 6 is less than or equal to 0. This is a quadratic that we can factor, and basically what we're trying to find here are where the zeros are. So we do want to try to factor this, and let's see if I can't get this on the first try here. We know the factor is going to look like this. So let's see here. I'm going to try what do I want to do here? 2x plus 3 and 3x minus 2. This is just, so basically what I'm doing is I'm trying to figure out two of the first terms need to multiply to 6x squared. The two last terms need to multiply to negative 6. And then if I multiply like these two terms and these two terms to get those two middle linear terms, like these two guys up here, I want their sum to be negative 5x. So if that works already, then we're good to go. If that doesn't work, then we need to try a different combination here. So let's see here. So we got these two right here. 2x times negative 2 is going to be negative 4x. And here 3 times 3x is going to be 9x. So if I combine those, I get a positive 5x. What I really want is a negative 5x. So what I wrote down here is not correct. I do need to swap some of these. So I think what I'm going to do is just basically change the position. Actually, I want the 9 to be negative. I want the 4 to be positive. So I'm going to not just change, I'm just going to change the signs here. And so this now multiplies to give me negative 9x plus 4x. That does give me the negative 5x. So that means I factored correctly. Erase all this. Okay, so once you've factored it correctly, we can find the zeros of the parabola. We know that this is a parabola that's going to open up because the leading term's positive. So if we're just doing like a rough little sketch here, and this is super rough, here's my x-axis. I know it's opening up. I'm going to find my two x-intercepts, right? And my parabola is going to do something like this. Now the question is asking, when is this less than or equal to 0? So it's really asking for what x values are below the x-axis. So as soon as we can find where those x values are, we can say that all the x values that make this negative or 0 are going to be contained in between these two x-intercepts. So right away I can eliminate a, b, and c, because even though I don't even know the solutions yet, or the not the solutions but the x-intercepts, the solution set has to be in between the two values because this this part that's below the x-axis is connected. If this said like greater than 0, then you'd have the two branches of the parabola that you'd be reporting back. So let's find the two x-intercepts here. What we'll do is set each one of these factors equal to 0 and solve them independently. So this would be like 2x minus 3 equals 0 and 3x plus 2 equals 0. So using those properties of equality, you should get x equals 3 halves and x equals negative 2/3. Those are going to be the endpoints of this interval, where this is at negative 2/3 and this must be at 3 halves. So our answer is going to be D. Another tough one. Couple tough ones in a row here. Number 26 says pump A and pump B, working together at their respective constant rates, can fill an empty pool with water in 3 hours. Okay, so we've got this pool. Okay, we've got two pumps, pump A and pump B, and they're now filling up this pool. Yeah, my art skills leave a lot to be desired here, but good thing this is not an art test. Okay, anyway, the setup here is a little tricky, okay, but we can get this up. So here's like some of the key points here. So it says that pump A, if it's going by itself, will fill the pool in 5 hours. Pump B, we're wondering if it works alone, how long does it take to fill up the pool? We know if they work together, it only takes 3 hours. So here are the key points here. The two pumps together, since it takes 3 hours for it to fill up, we know that it can fill 1/3 of the pool in 1 hour. All right, because it takes 3 hours to fill up the whole pool. Okay, pump A is going to fill 1/5 of the pool in 1 hour, and pump B fills the pool, or we don't know exactly how much, and that's what we're actually trying to find, x of the pool in 1 hour. Basically what we're doing is we're trying to take the information that was given to us and rewrite it in terms of just 1 hour. So instead of coming up with an expression of like how many hours per one pool, we're trying to come up with an expression to represent how much of the pool in 1 hour, so that way we can write an equation that relates all these. So here's how that equation is going to look. We've got pump A, which is 1/5, plus pump B, 1 over x, is equal to 1/3. So this is like pump A plus pump B is the total. And so basically at this point, we're just going to solve this equation for x. You're welcome to go ahead and actually, let's just solve this out. You really, if you got this equation set up, this is another like plug-in for x kind of problem where you can take the answer choices and figure out which one works. But I think this one is like really not that hard to solve, so I feel like maybe we should just solve it. Get a calculator, so it shouldn't be too bad. First, you would subtract 1/5 from both sides. That'd be 1 over x equals 1/3 minus 1/5. You could put this in a calculator, but 1/3 minus 1/5 is going to be 2/15. And then if we cross multiply and divide, we're going to get 2x equals 15, which means that x is 7.5. So our correct answer here is going to be B. And there's number 26. Number 27 says, what's the solution to this equation? Oh, great, another solve for x kind of problem. So that's what I would do here, honestly, is just plug in all these values, all these answer choices for x, and see which one's right. If you do want some more practice, like with log properties, we've seen a couple here that require that you know how to use the log properties. If you're looking for similar problems on the practice test that are like this, I would look at numbers 38, which is like more of a solving problem, and number 55, which is simplifying using properties, but there's really not a question where you have to do both in one problem like you have to do here. But again, I wouldn't even like mess with those logarithm properties. I would just plug in these answer choices as you get them. So let's start with A. Now, I don't know why the College Board does this, but whenever they have log base 10, they actually write out the 10. When normally you don't see that written. On your calculator, you're going to see that you have a log button. You don't see the 10. If you see log with no base written, typically it's assumed to be 10. So it's kind of odd that they would actually write 10 here. But my only thought is maybe they're just trying to remove any ambiguity, potential ambiguity here on what the base is. So I'm going to write it without the 10 just because that's pretty conventional and I think it'll be easier to read. But just know that if you don't write a base, it's typically assumed to be 10. Okay, well anyway, we're going to plug in 10, so here we go. 2 times log 10 minus log of 1/5 times 10 minus 1. We want to know, does that equal 2? Hopefully it does, and we could be done. If not, we'll just try the next answer choice. 2 times log 10. Where's my log button? I was just talking about it. There it is. So 2 times log 10 minus log of 1/5 of 10, that would be 2, minus 1, and look at we got 2. So, we saw one earlier where we had to go through all the answer choices to get the right one. Sometimes you get lucky, and here we go. The answer is A. Number 28 says, a line intersects a circle with center O as shown in the XY plane above. The circle region represents the solution set to which of the following systems of inequalities. So here you just have to know how to write an equation for each one of these. Now, it does appear that the radius here is 1, so we actually have the unit circle here. And the equation for a circle with a radius of 1 is going to be x squared plus y squared equals 1. Okay, so that's going to be this one. Now, notice that the shading is on the inside of the circle. So instead of this being equal to 1, we're going to say that it's less than or equal to 1. If it was greater than or equal to 1, we would be shading all the points that are further away from the origin, rather than the ones that are closer. And then we also have this other equation, which has a y-intercept of -1 and a slope of up 1 over 1 would just be 1. So this line is going to be y equals x minus 1. And since it's shaded above, we're going to change that equals to a greater than or equal to. And there's your two equations. It's just asking you to identify which equations you see here. This problem's kind of like number 47, which is where you have to solve a system of equations that has a circle, but there's nothing like exactly like this on the practice test. Let's look for our answer choice here. Looks like it's going to be B. Number 29 says the function is defined. We've got a piecewise function. what's the value of f of 2 plus f of negative 2 plus f of negative 3? So basically what we need to do here is evaluate each of these, and then we can answer the question. We're going to add these together. So it says, what's f of 2? Now for a piecewise function, you basically are going to plug it into the correct piece based on the domain restriction. So negative 2 is greater than or equal to negative 2. So for this first one, we'll plug in negative 2 right there. Negative 2 squared minus 1. 2 squared is 4, minus 1 is 3. And then if we're going to substitute in negative 3, that is a number that's less than negative 2. So we're going to plug it up here in the top one. Negative 3 plus 6 would be 3. So the value of f of negative 2 plus f of negative 3 should be equal to 3 plus 3, which is 6. So our answer is B. All right, we're flying through with these problems. Hopefully I'm not going too fast for you guys. Number 30. If f of x equals 85 minus 6x and g of x equals x squared, what's the value of f minus g at x equals negative 10? Well, here is just like kind of like the last problem, where we're just going to plug in negative 10 and see what this thing equals. So first we'll find f of negative 10, and then we'll also find g of negative 10, and then instead of adding them like we did the last problem, we'll subtract them. So f of negative 10 would be 85 minus 6 times negative 10. And just to make sure I don't get anything wrong here, especially because there's no answer choices for me to work with, I'm going to type this in the calculator. That way I can blame the calculator if anything goes wrong. We got 145. G of negative 10 would be negative 10 squared, which is, don't need a calculator for that, that's just 100. So 145 minus 100 is going to give us 45. There you go. There's number 30. Number 31 says the function g is defined by g of x equals x plus 1. If h is the inverse of g, what's the value of 2? So the inverse of y equals x plus 1 is, like if we were going to solve for x here, we would subtract 1 on both sides, right? We get y minus 1 equals x. So this is the inverse, okay? So h of x is actually going to be like this expression, but we're going to replace y with x, so x minus 1. So if we want h of 2, we're going to say h of 2 is 2 minus 1, which is 1, and that's our answer, it's C. Number 32. 3 savings account, R, S, and T, were opened on the same day, and the same amount of money was deposited in each account. The table shows the amount of money in each account T years after the deposits were made. Based on the table, 6 years after the deposits were made, account blank had the greatest amount of money and contained approximately blank more than the account that had the least amount of money. So what we need to do is find how much money was in each of these 3 accounts after 6 years, and then we'll pick the one that has the most and subtract the one that has the most minus the one that has the least to get the difference here. Now this one, I have 2 blanks here. The kind of problem that this is going to be is not going to be a drag and drop. It's not going to be a fill in the blank. It's almost like a double multiple choice. These are going to have little drop down menus that you click on, and then it gives you options. So yeah, basically we're going to plug in 6 in for T. Okay, 6 years after the deposits were made, and we're going to find how much money is in the account for each one of these. So 100 times 1.03 to the power of 4 times 6 is going to be $203.28 for account R. For account S, we've got 100 times Euler's number to the power of 0.06 times 6. And that's going to be $143.33. And then finally, we've got 100 times 1 plus 0.1 times 6, 160. Okay, so the one that had the most was account R. So account R had the greatest amount of money and contained about how much more than the one that had the least. So the one that had the least is this 143 number. So I'm going to just subtract those two. 203 minus 143 with the decimals included and everything. And so it should be approximately $59.95 more. All right, number 33, done. Wait a minute, or 32, done. 33. The graph of which of the following functions in the xy plane has more than one x-intercept. So the x-intercept is where the graph crosses the x-axis. And so you have to have at least a decent idea of what these graphs are, since you're not going to get a graphing calculator. And you don't have to know exactly what they look like, but if you have just like a general idea what they look like, you can answer this one. So the first one, negative 4x minus 5, that's going to be a linear function. It's got a negative y-intercept with a negative slope, so it's basically going to look something like this. Any linear equation is only going to have one x-intercept, and we're looking for the one that has more than one, so it's not going to be A. B is a quadratic. It's got a negative a value and a positive y-intercept, so the negative a value tells you that it's opening downward. Okay, so it's going to go like this. Now this is going to be our answer, okay, but I want to at least explain why it's not any of the other answers. Here we've got two x-intercepts. Okay. C, whenever you don't see an x, that's just going to be a horizontal line going through, in this case, 4. That has no x-intercepts, so that's not going to work. D is another quadratic, but since the leading coefficient is positive, that means that this is going to open up. It's got the same y-intercept as B, but since the leading coefficient is positive, that parabola is going to open up and have no x-intercepts, just like C. Finally, E is a cubic function that has a y-intercept of 5. And so it's going to do something like this, and it's going to cross the x-axis just once, so it's not going to be E either. The only one that has more than one x-intercept is B. Number 34 says the tables above list some values of 3 functions, and we got one for f, g, and h. It says which could be a linear function. Now there's not really like a table analysis kind of question on the practice test. You just really need to be familiar again with slope and how to calculate that. So if we're testing to see which one's linear, the key characteristic of a linear function is that it has a constant rate of change, meaning the rate of change doesn't change. So what you're looking for is as x goes up, you're looking for the amount that y goes up or down by to be constant, should not change. So like if we look at f, for instance, we can see that we're just adding 3 each time, right? So this would definitely be an example of a linear function. F is going to be good. So yeah, our answer is going to be either A, D, or E. We can say it's not going to be just them because we found one that was linear that wasn't those. It wasn't G or H. So let's try G. We can see that we're adding 1 here, but then we add 2. So there is a pattern here, but it's not linear because the rate of change is not constant. That allows us to eliminate E. And for H, we are adding 4, adding 4, adding 4, and adding 4. So we're adding the same amount for each increase in x. And so this is going to be another linear function. So the two linear functions are going to be f and h. Number 35 says the retail price of a certain item at a store is x dollars, where x is greater than 5. If a coupon is used that reduces the retail price by $5, the reduced price R in dollars of the item is given by the function r of x equals x minus 5 for x greater than 5. Okay, so basically they're giving you a function to represent the reduced price, but then they're also giving you a function later. It says after the 5% sales tax is charged by the store on the reduced price of the item, the cost in C is given by this function C of R, which of the following gives the cost of the item as a function of the retail price X. So, wow, this is a very wordy problem, and I think what we're going to do here is set this up as a composition of functions. So we know that R of X is X minus 5. We know that C of R is 1.05R. And what we're trying to do is figure out what's C of X. And so to get C of X, we need to substitute this function for R of X into C. So it's going to be 1.5, and instead of writing R, I'm going to write what R equals in terms of X. So I'm going to replace that R with X minus 5. And that's it. It's a very wordy problem to do a very basic algebraic step here, which is just one case of substitution. You just, I guess you got to know kind of what it is they're asking for. The whole x greater than 5 business is really extra information that you don't need. So anyway, this would be our answer. Number 36 says the graph of the function y equals f of x is shown in the xy plane above. Which of the following is f of x plus 2? So this is a transformation on a function, and specifically this plus 2, when you see that on the inside of the parentheses, that causes a shift to the left 2 units. So the new graph should look kind of like this. I'll draw it on top of the original graph here. What I like to do is take this vertex here, or just any kind of key point, and start with that, shift that to the left 2 units. So this vertex would go over here, and then pick maybe a couple other points just to kind of make sure you're transferring it over correctly. Like this point right here, I'll shift that over 2 units. Same thing with this one, and so we get a graph that looks something like this. Okay, so basically what I'm doing is I'm shifting this 2 units to the left, and so I'm looking for the graph which shows that, and yeah, I see it right here. Okay, so when you're given a graph or a function that's in this form, x minus h plus k, the h is going to cause a horizontal shift here, and the k will cause a vertical shift. In other words, shift it up or down. It is kind of weird how the horizontal shift actually goes the opposite direction that you might actually think. Like this says plus 2, but it's going to the left. But, you know, for the sake of brevity, let's just accept the fact that, yeah, the horizontal shift is going to go in the opposite direction that you might think. The vertical shift, like if you add 5 to a function, for instance, it would shift up, kind of goes in the direction that might be a little bit more intuitive. So anyway, our answer is C for number 36. You know, there was a problem kind of like this just before we move on the practice test. You could take a look at number 56 if you want to get something that's kind of similar to this problem. Number 37 says the amount of coffee consumed annually in country X increases by 8% each year. If 970,000 metric tons of coffee were consumed in country X in 2000, which of the following functions C can be used to model the amount of coffee in thousands of metric tons consumed annually in country X, where T is the number of years since 2000? What we're doing here is trying to set up a exponential growth function. There's one just like this on the practice test, number 73. But for this particular one, the way you're going to set up an exponential function is going to look like this. C of t equals your initial, I'll just put a here for now, but that's your initial amount times b to the power of, I guess in this case it would be t. And so the initial amount here is going to be 970. Okay, we're measuring in thousands of metric tons, so we don't need to put all those extra zeros. And then b is our either growth factor or decay factor. In this case, it is exponential growth. So we're going to take 100%, which is the amount that you start with, and then each year you increase by some number of percent. In this case, we can see that it's 8%. So what we want to do is add the 100%, which is 1, to the 8%, which is 0.08. And that's pretty much our answer here. We want to make sure that we combine the 1 plus 0.08 so that we can see our answer in the answer choices here. We get 1.08 to the power of t, and so our answer is C. And that's it for 37. Number 38 says the function h is a product of functions f and g, where f of x is e to the x and g of 0 is 2. Find the value of h of 0. So overall, you just need to understand function notation with this one. There's nothing exactly like this on the practice test, but actually it's not too hard. You're just trying to find what is h of 0. And h is the product, meaning we're going to multiply f and g. So what we really want is f of 0 times g of 0. Now, g of 0 is given, okay, so that's going to be pretty easy to find. And then for f of 0, that's what we're going to get when we plug in or substitute 0 into this function for f. So it's going to be e to the 0th power times 2. G of 0 is 2. So we have e to the 0 times 2. So again, we're coming back to these exponent properties. And I really hope that you're seeing by now that you really got to know your exponent properties. And the one thing you got to know here is that when you raise something to the 0th power, it equals 1. So we have 1 times 2, which is 2. Our answer is A. Number 39. A company produces at most 200 items of its product per day. The daily profit P in dollars can be modeled by the function P of n equals 3.5n minus 70, where n is the number of items produced per day, and n is at least 20. What is the range of the function? Ooh, range. We haven't really talked about domain and range yet. Our function is P of n equals 3.5n minus 70, but only for when n is greater than or equal to 20. So what we need to do is figure out, okay, well, what's happening when n is 20, and then what's happening after that? So if I substitute 20 in for n, we've got P of 20 equals 3.5n, so 3.5 times 20 minus 70. I'm going to use the calculator here to actually compute that out. Okay, we'll get 0 there. Was not expecting that. So we get 0. So that's going to be either our minimum or maximum value for the range or the output. Now we can see that in the function for P, the rate of change or the slope is positive. We can see it's 3.5. Let me redraw that because I don't want you to confuse the n as being part of the slope. But since that rate of change or slope is positive, that means as n increases, so will P. So that means that our range is going to consist of all values that are bigger than 0 and including 0. So let's take a look at our options here. There's a set of all real numbers. Okay, that's not right because we're going to actually start at 0. Set of all integers greater than 0. It says greater than 0. I really want it to be greater than or equal to 0, so I'm going to say that B is not right. Is there something else that we're missing here? The set of integers from 20 to 200. No. The set of multiples of 3. Okay, so what's the deal with the 3.5 here? We cannot, because we're only dealing with integer inputs, we're not going to have any outputs in between. Like, in other words, like we're not going to have an output for P of like 20.5 because n represents the number of items produced per day, and we're only going to consider like whole numbers here. So if P of 20, or if n equals 20, is going to be the minimum, going to give me the minimum value, if I plug in like 21, that's going to be 3.5 more than 0, right? And if I plug in 22 and I calculate this out, 3.5 times 22 minus 70, that's going to give me 7. And so what you're noticing here is that my outputs, they are increasing. So it is all the numbers greater than or equal to 0, but not all numbers, just these specific ones, which are multiples of 3.5. Now, it says that the company produces at most 200 items, so our maximum would be where n is 200. So if I substitute 200 in there, let's see what this is going to equal. 200 times 3.5 minus 70, and that gives me 630, which is why this answer choice says that the maximum number for the profit is 630. So, yeah, our answer is going to be E here. It's going from 0, which is what our minimum P value was, all the way up to 630. And since we can't create, we're not going to consider like selling, half of an item, right? Whoever's buying that might be a little upset. So we're only going to consider when n is an integer. And we see that our outputs are just multiples of 3.5. So that's our answer for number 39. Let's take a look at number 40. Number 40 says the graph of a quadratic function is shown in the xy plane below. The x-intercepts are 3, which we see here, and -1, which we see here, and the y-intercept is 2, and it's asking what is the y-coordinate of the vertex. Now the vertex is this point right here where the slope changes from positive to negative, and we can identify that with a set of coordinates, x, y, and we need to figure out what that y-coordinate is. So I think the easiest way to do this is to come up with an equation for the vertex and then calculate out what that maximum would need to be. So we know that the x-intercepts are -1 and 3, so for sure our function here to generate this curve is going to have two factors, x plus 1 and x minus 3, okay, to correspond to these x-intercepts of -1 and positive 3. Okay, now the problem here though is that if I multiply these two binomials together, you'll see that the y-intercept that I get when I multiply 1 by -3 is -3, right? But I want that y-intercept to be 2. So what I need to do is to multiply this function by a constant to force that y-intercept to be 2. So the question is here, like, what do I need to multiply? This is jumping around all over the place. What do I need to multiply negative 3 by? I'll just call it a to get to 2, where I want the y-intercept to be. And dividing both sides by negative 3 here is going to give me negative 2/3. So if I multiply my function by negative 2/3, now I've got the function for this graph. If I want to figure out what the vertex is, I need to figure out what this coordinate is. Now I know that the x-coordinate of this vertex has to be 1 because it's got to be halfway in between the x-intercepts. So notice like this distance is 2 and so is this one over here. So that means that the x-coordinate on my vertex is 1, and so to find the y-coordinate, all I need to do is just plug that into x. So I've got y equals negative 2/3 times 1 plus 1 times 1 minus 3. I would probably just go ahead and put this in the calculator. I'm going to do the addition and subtraction here just to kind of get it set up. We've got negative 2/3, I'm going to type that in, times 2 times negative 2, and that gives me 8/3. So that means the y-coordinate of my vertex is 8/3. As far as this problem goes, this is a little like number 56, again, like we saw before, and also like number 77, where you have to understand what the vertex of a parabola is. But this one is a little bit different because you have to actually come up with the equation. So make sure you know how to set up this equation using the x-intercepts and the y-intercept, and then all you have to do is just plug in the x value of the vertex. Number 41 says the function f is defined by f of x equals 1/2 x minus 1. Which of the following functions is the inverse of f? So yeah, the easiest way to find an inverse is if I start with the original equation that I had, the easiest way to find the inverse is to swap x and y and then solve for y. So first I'll swap the positions of x and y, and that's really what an inverse is. It's just a reversal of the inputs and outputs. So now I'm going to solve for y. First I'll add 1 to both sides, and then I'll multiply everything by 2, and there you go. Here is my inverse of f. It's 2x plus 2, and according to the problem, we're calling that inverse g. Our answer here is going to be e. Number 42 says, what is the domain of the function f of x equals square root of x plus 2 divided by the absolute value of x minus 1? Now, on the practice test, you do need to know how to find the domain of different types of functions. Like for instance, number 50 on the practice test, you have to understand the domain of a logarithmic function. On number 59, you've got to understand how to find the domain of both a rational and a square root function, like you have to do on this one. Number 65 on the practice test is another domain of a square root function question. And then number 79 asks you to, not directly, but you have to know how to find the domain of an absolute value function. So there's all these different types of functions, absolute value, rational, square root, logarithmic, that you should be generally aware of what the domain restrictions are. So let me just kind of go through that. So if you have a square root function, then the domain is going to be everything that is greater than or equal to 0. Because in order to get a real number out of this, you have to take the square root of a positive number or 0. If you try to take the square root of a negative number, you get an imaginary number, and that's not going to be contained in the range if we're only considering reals. If you have a rational function, like 1 divided by something, or just any fraction, you're not allowed to divide by 0. So the domain here would be basically anything except for 0. If you've got an absolute value function, there is no restriction on this domain. Okay, so x could be anything, and so there's no additional restriction for an absolute value function. Now the range will be affected there, but this isn't asking about the range. The last thing, even though this problem doesn't ask for it, I did see it on the practice test. You should be familiar with the domain of a logarithmic function, which is kind of similar to the square root function, except it can't be 0, so just x greater than 0. So we've got all these different restrictions for different functions, and so when you have one that has a bunch of different functions all together, you have to consider all the restrictions separately. So let's start with the square root function. So the square root of x plus 2, right, means that x plus 2, or this number underneath the square root, cannot be negative. So it has to be either greater than or equal to 0. Okay, now solving this for x, I get x is greater than or equal to -2, and so that's part of the domain restriction. The other part that's going to restrict the domain is going to be this denominator that cannot be 0. The absolute value of x minus 1 can't be 0. That means the absolute value of x can't be 1, and the absolute value of both 1 and -1 equal 1. So that means x can't be 1 and it can't be -1. So the bottom line here is we've got this number line. There are certain numbers that are not going to be in the domain, meaning you can't just plug them into x and get a real number output. Okay, so those numbers are going to be the -1. We cannot have that in our domain. We can't have 1 in our domain. And our domain's also going to be restricted by the fact that it has to be greater than or equal to -2. So let's throw in -2 here and show that we can include -2 in our domain and every number bigger than it, except for these little holes here, due to the denominator. So if we're trying to write the actual complete domain here, it would be in between -2 and -1. So including -2, we put the bracket. Not including -1, we put the parenthesis. Union -1 to 1, so everything in between here, but not the endpoints. And then finally, 1 to infinity. And so our answer here is going to be D. I think drawing it on the number line can really help. You get a sense of what the domain should be, but ultimately you have to know like what it is allowed to be plugged into x for each one of these functions. Number 43 says, let f be a function such that f of x equals f of -x. The fact that this is true for this function they're giving us means that we have a function. Basically, the idea is for an even function, if you plug in any number, so let's say I plug in 2 and I plug in -2, then the outputs will be the same. So if the inputs are opposites, the outputs are the same. So if -2, 4 is a point on the line, then also 2, 4 has to be on the line, and so that's going to be our answer, E. With an odd function, even though this question isn't asking about that, if it was odd, then the outputs would be opposite. So like if I had 2, 4, then I would also have a point at -2, -4. So this would be if it were an odd function. This one isn't, but I figured I might as well just give you a little something there to work with. Okay, number 44. We're given a list of points, and it says the relation shown consists of ordered pairs. If y is a function of x, that's going to be our key phrase there. Y is a function of x. Which of the following cannot be true? Okay, so in order for y to be a function of x, the definition of a function is it's a relation where each input has exactly one output, meaning an input cannot have two different outputs. So for example, A couldn't be 1 because 1 is going to 4 already. 1 can't go to 5 in a function. Okay, B, there's not going to be any restrictions on B, okay, because B is an output and your outputs are allowed to repeat. What's not allowed to repeat are your inputs. In a function, each input has exactly one output, so it's really the A value that can't be 1, can't be 2. Well, I guess unless this was the same point, I suppose that could be true. It can't be 3, can't be 4. So let's see what our options here are here. Which of the following cannot be true? A is 0. Well, yeah, A is 0, so that could be true, so we're not going to select that. A cannot be 1, right? If A was 1, then we would have two outputs for x equals 1. And that is a problem for a function. Now, just understanding what a function is going to be important probably for like maybe 1 or 2 questions. There was a problem, number 34, on the practice test that asks you to identify what relation is a function. And on that problem, they gave you 3 different representations: the table, the graph, and the equation. So you have to be able to identify a function just from that alone. Here we've got a list of points, which is basically like a table. And so in order to understand whether or not a relation is a function, you have to understand that a function is a relation where and this is the key part, where each input, the x value, has exactly one output. So in other words, you can't have an x value that has two different y values. So I can't have 1, 4 and 1, 5. The rest of these would be okay. Number 45. The first term of, okay, so this is not a multiple choice. We got to fill in the blank here. It says the first term of an arithmetic sequence is 120, and the third term is 170. What is the eighth term of the sequence? Now, I was kind of wondering when an arithmetic sequence, or just really any sequence or series problem, was going to pop up, because I know there was several on the practice test. This is the first time we see it, and something that kind of stands out to me is this is an arithmetic sequence versus a geometric sequence. So a geometric, which is what we see a lot on the practice test, is basically like an exponential function, just with a restricted domain. An arithmetic sequence, which is what we have here, is basically like a linear pattern, where you're either adding or subtracting the same amount for each term. To figure out the eighth term, we know the first term is 120, so I'm going to just say a sub 1, meaning the first term is 120, and the third term is 170. So if I'm trying to figure out the rate of change here, I'm adding 50 to my term value, and I'm adding 2 to the term number. To calculate the rate of change, we divide the change in y divided by the change of x, or the change in output divided by the change of input. So my rate of change is going to be 50 over 2, which is 25. And basically what this is saying is that each term is going to be adding 25 to the previous one. We could set up an equation for this and plug in 8, but these numbers are pretty small, so I'm just going to use the calculator. So I'm going to start with 120, and I'm just going to successively add 25 until I get to the eighth term. I'm going to start with 120. I'm going to add 25 just to make sure that my third term's good. What was I? Okay, so 120 plus 25 plus 25 again is 170. Okay, so we're good here. And then plus 25 again. So 195 is what I get for a sub 4. And then we're going to add 25 again. That's 220, 245, it's a sub 6. Seventh term would be 270. And finally, the eighth term would be 295. So yeah, this one would be 295. Number 46 says the polynomial function is defined by f of x equals x to the fourth minus 16. For how many distinct real values of x does f of x equal 0? This is another difference of two squares problem. We did that earlier in this video in number 4. You can go back to that one if you want a little bit more detail, but basically the difference of two squares says that you can factor any expression that is a difference of two squares. Basically, if you have a squared minus b squared, you can factor that as a plus b times a minus b. So if this is a squared and this is b squared, my a would be x squared, because x squared squared is x to the fourth, and my b is going to be 4, because 4 squared is 16. So that means that x to the fourth minus 16, which we want to know how many real values equal 0 here, we can factor that as x squared plus 4 times x squared minus 4. Now notice we have x squared minus 4. This is another case where we can factor that using a difference of two squares. In this case, my a would be x and my b would be 2. This other factor we cannot factor further. So here's our complete factorization for this fourth degree binomial. And so to find the zeros, you would set each one of these equal to 0 and solve. Now it's not actually asking for the zeros, it's just asking how many zeros you get. And usually with the quartic you get 4 zeros, but sometimes the zeros are not real. And that's kind of the point with this question, is to understand when you get a real zero and when you don't. So these two factors will produce real zeros. If I set x plus 2 or x minus 2 equal to 0, I can solve those pretty easily and get x equals negative 2 and x equals 2. These are both real numbers, so we have at least 2 real zeros. But if I try to solve this other one, I get x squared plus 4 equals 0, and I try to subtract 4 from both sides, and you can see what's going to happen here is I need to take the square root of a negative number, and that produces an imaginary or a complex number, not a real number. So there's really only 2 real zeros to this equation.
And here we have another free response problem. So we're going to have to work this out by hand. It says the nth term of an arithmetic sequence is 12 minus 4n. What is the second term of the sequence? So yeah, we get another free response arithmetic sequence problem. So be ready for these. It says that the sequence is defined as 12 minus 4n. What is the second term of the sequence? So really all I have to do here is plug in 2 into n. So we get 12 minus 8, which is 4. So the second term of the sequence is 4. Number 48 says if a is 2 plus 3i and b is 3 minus 2i, then a minus b is equal to which of the following? So here we've got 2 plus 3i as a, okay, and b is 3 minus 2i. So really we're just going to combine like terms here. There's really not much to this one. Complex numbers don't show up too often on the practice test, and honestly this one's like an easier version of number 44 because you don't have to do any multiplication. You're just going to combine like terms. So first I'm going to apply this subtraction to both terms in the second polynomial, kind of like using the distributive property. And so this would be minus 3 plus 2i, and then I'm going to combine like terms. So 2 minus 3 is negative 1, and then 3 plus 2 is 5, so we get negative 1 plus 5i. So negative 1 plus 5i is going to be choice B. Number 49 says if 0 is less than r is less than s is less than t, which of the following cannot be true? So this is very similar to problem number 22 on the practice test, but really we can work it very similarly to how we did number 6 earlier on these problems, because you can just plug in values that work for r, s, and t and probably get the right answer here. So I'm just going to pick some values that will work for r, s, and t, some simple values, like since these have got to be bigger than 0, and they go in order here, I'll let r be 1, s be 2, and t be 3, and then just see which one of these answer choices works. Or actually, which one does not work, because we're looking for the one that cannot be true. So if I plug these numbers in, we'll just see, and if we get 2 right answers, we might need to change the numbers, but most of the time this works on the first try. So here we have 1 squared, 2 squared, 3 squared, and yeah, that's going to be true, right? 1 is less than 4 is less than 9. For part B, we've got r times t, so that's 1 times 3 is less than 1 times 2. And that is not true. 1 times 3 is 3, and 1 times 2 is 2. 3 is obviously bigger than 2, so this is most likely going to be our answer unless we happen to come up with another one that's not true, and then we'll try to narrow it down from there. Part C, or letter C, choice C, whatever you want to call it, 1 over 3 is less than 1 over 2, is less than 1 over 1. This is true, right? 1/3 is smaller than a half, which is smaller than 1. Choice D has s over r, so that'd be 2 over 1 is less than t over r, which is 3 over 1, and yeah, that's true too. 2 is smaller than 3. Finally, choice E, you've got 1 over 3, that's r over t, is less than r over s, which is 2, and in fact, yeah, 1/3 is smaller than a half. We already established that back on option C, so for sure our answer here is B. Number 50. All right, so we had a couple of arithmetic sequence questions earlier, and now we've got a geometric sequence question. We said earlier that a geometric sequence is kind of like an exponential function. The only difference is the domain is only positive integers rather than all real numbers. So it says the sum of the first n terms of the geometric sequence is given using this formula. Okay, this a sub 1, that represents the first term. And they actually tell you, they really spell this one out for you, so you don't need to know these formulas. That's kind of nice. And r is the ratio, so that's like if you were to take some term and divide it by the previous term, that would be the ratio. What is the, I think we're missing a word here, what is the sum of the first 12 terms in the geometric sequence? So we need to add all these up. We have a formula for it, so we don't have to do it manually, although you could. Like if you just write out all these numbers, you could find the first 12 values, and clearly here we're just multiplying by 2. So you could just keep this pattern going, find the first 12 numbers and add them up using a calculator, but they do give us this handy formula to do it a little faster. So a sub 1 is the first term, and that's 1. That's our a sub 1.
So 1 times the r value is the common ratio. That's the number you're multiplying by every time. So that would be 2. So 2 to the power of n minus 1 over r, again that's 2, minus 1. So just to simplify these a little bit, since multiplying by 1 doesn't do anything, and 2 minus 1 is 1, we've got 2 to the power of n minus 1 over 1, which is 2 to the power n minus 1. So if we want to find the sum of the first 12 terms, then we're going to use n as 12. So 2 to the power of 12 minus 1, I'm going to have to break out the calculator here. This is going to be 4,095. And that would be the sum of the first 12 numbers. Now, if you get confused with that big formula, again, you could just find the first 12 numbers and then just add them up using your calculator, so that does work. But this is a little faster if you can make sense of that formula right there. Number 51 says the polynomial function f is defined by f of x equals x cubed minus 3x squared plus 3x minus 2. If 2 is one of the roots of f, which of the following is also root of f? So what we need to do is we actually need to factor this out to figure out the other roots, right? So if 2 is one of the roots, that means x minus 2 is one of the factors. So like we can rewrite this f of x as x minus 2 times some quadratic. Like there'll be something times x minus 2 that equals that original function. So to find that out, we need to do a little division here. And we'll use a technique called synthetic division. So you put that number, that first root, on the outside of this like L shape. And then you'll take each of the coefficients of the polynomial, in this case 1, -3, 3, and -2, and write those numbers going horizontally here. And then to execute this synthetic division, you're going to first bring down the first number, which is 1. 1 times 2 is 2, and then add 2 plus -3 is -1, and just repeat that process until you get to the end. -1 times 2 is -2, plus 3 is 1, 1 times 2 is 2, plus -2 is 0. So this actually verifies that 2 is one of the roots, because this number that we got a 0 for, that's the remainder. If you have a remainder, then that means that 2 would not be a root. So that's good news that we got a 0 there. And so these numbers that we're getting at the bottom are going to be the coefficients of the quadratic. That's going to be the other factor other than x minus 2. So in other words, this is going to be like 1x squared minus 1x plus 1. That's going to be the other quadratic we'll put over here. I don't need to write those coefficients of 1, so I'm just going to write x squared minus x plus 1. So at this point, we need to find the roots or the solutions to where that other factor equals 0. So to do that, we're going to use the quadratic formula. This one is not factorable. We're going to have to use that quadratic formula. So my other two roots are going to be x equals -1, that's positive 1, plus or minus the square root of -1 squared minus 4 times 1 times 1 divided by 2 times 1. And normally I would say go ahead and just put this in the calculator, but these numbers are so small. I mean, you might double check in the calculator, but I think you might be able to compute this without one. 4 times 1 times 1 is just 4. -1 squared is just 1. So this is like 1 minus 4. So that's -3. And then 2 times 1 is 2. Okay, so just to simplify these roots out, we've got 1/2 plus or minus the square root of -3, which we can rewrite as the square root of 3i, since the square root of -1 that's I, over 2. And so here's our two other solutions here. And so we're just looking for one of those. I see it here. It's choice C, but this one's missing the little I here. Right? So yeah, the answer here is going to be choice C. Number 52, got a word problem. There were 218 sea turtle nests on a certain beach in 2017. Environmentalists are working to protect the turtles, and they predict that the number of nests on the beach each year after 2017 will be 1.5% greater than the number of nests on the beach in the preceding year. According to the prediction, which best represents the number of loggerhead sea turtle nests that will be on the beach in 2000? So this is going to be another exponential growth problem. We've already seen one of these. This is basically just a repeat of question 37 from earlier. And again, just like that problem, it's very similar to number 73 on the practice test. So yeah, we're just setting up an exponential growth problem. That's going to take the form y equals a times b to the x, where a is the initial value and b is the growth rate. So our initial value here is going to be 218. That's how many sea turtle nests there were in 2017. And then since each year it grows by 1.5%, we're going to take the 100% that we start with. That's the 1. 100% is just 1. And then we're going to add 1.5%, which would be 0.015, raised to the x power. Although in this case, we're looking to see how many there would be in 2020, and that's 3 years after 2017, so the x here is just going to be 3. This is basically our answer here. Since we don't have to evaluate anything, we just need to set this up. The only difference between what we see in the answer choices and what we have written is the 1 plus 0.015 combined. So this is 1.015 to the power of 3, and our answer is A. Number 53 has us multiplying two complex numbers. So this is the second problem we've seen with complex numbers. Not a ton, but a little bit. This particular one is extremely similar to number 44 on the practice test. So if you want another example, you can look at that. Really, the big difference here is it doesn't actually separate out the I. And I might do that just to make this a little easier and say this is root 16I and 2 minus, oh, actually this one works out even easier than I thought when initially looking at this, because root 16 and root 25 are actually, those are perfect squares, 16 and 25. So I'm actually going to rewrite this one last time as 3 plus 4i times 2 minus 5i. So now we've got two binomials that we need to multiply. We can use the distributive property to do that. Sometimes you'll hear this called FOIL, first, outside, inside, last. Or sometimes you'll see the box method as a way to organize these steps. But basically we want to do 3 times 2. That's 6. 3 times negative 5i would be minus 15i. 2 times 4i is going to be 8i. And then 4i times negative 5i is going to be negative 20i squared. Combining like terms will give me 6 minus, what would that be? 15, that'd be 7i minus 20 times I squared. Now one little extra fact that you should be aware of is that I squared is negative 1, and that's because I is the square root of negative 1. So if you square both sides, you get negative 1. So that means this little I squared here is negative 1. So really this term is negative 20 times negative 1, so it'd be positive 20. 6 plus 20 is 26. So we get 26 minus 7i. We can see our answer choice down here, it's E. Number 54. Which of the following is equal to 3 factorial over 3 factorial? I think there was one problem on the practice test that even had factorials on it. This one's kind of similar. The big difference here is that on the practice test, there was no actual number in here. It was in terms of n, so it was a little bit trickier. This one's a little easier because you have a number to work with. But basically, when you have any number factorial, that means you multiply that number by the number that came before it. Here's sort of the generic format here, but basically you multiply whatever the number is right before the exclamation point by each positive integer that came before it. So for instance, 3 factorial is going to be 3 times 2 times 1. That's what 3 factorial is. And so we'll say that's factorial over 3 times 2 times 1. Now 3 times 2 times 1 is, 3 times 2 is 6 times 1 is, so that's just 6. So this is really like 6 factorial over 3 factorial. But you know what? I'm going to write that as 3 times 2 times 1. Okay, so 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. And we can see that we're going to have, the 1s will reduce to 1, obviously. So the 2s and the 3s. So we get 6 times 5 times 4, which is 30. I'm not going to double check this in the calculator. We got 30 times 4, I think it's 120. 6 times 5 times 4. Yeah, it is 120. So we need to find which of these equals 120. Now 2 factorial is 2 times 1, that equals 2, so it can't be that. 3 factorial is 3 times 2 times 1, that's 6. If we multiply that by 4, that's going to be 24. If we multiply that by 5, that's going to give us the 120, and that's going to be our answer. So yeah, there's number 54. Getting pretty close to the end here. Number 55 says if A is square root of 45 and B square root of 20 and C square root of 5, which of the following numbers are rational? Indicate all such numbers. So a rational number is going to be one that you can write as a fraction where both the numerator and the denominator are whole numbers. So typically square roots are not going to be rational unless you're taking the square root of a perfect square, but something like square root of 7 is not something that you can write as a fraction where the numerator and denominator are integers. This problem, or this concept of is a number rational versus irrational, is reflected on one of the problems on the practice test, number 20. But this one is a little bit more direct because you have some defined numbers to work with, and that problem on the practice test was purely variables. So here we're just going to basically test, each one. Now what I'm going to do first is rewrite each of these square roots in simplified form, so that when I go to check all these answers, I think it'll be a little bit more obvious which one's going to be rational. So square root of 45 is the same thing as 9 times 5. Square root of 9 is 3, so this is 3 root 5. Square root of 20 can be written as 4 times 5. Square root of 4 is 2, so this is 2 times root 5. And so, yeah, square root of 75 is going to be 25 times 3. So this will be 5 times the square root of 3. Okay, so let's go through these answer choices and see which one is going to work for us. So A over B, that's going to be 3 root 5 over 2 root 5. The root 5s will reduce, so this is just going to be 3 halves. That is rational. Basically what we're looking for is for all the square roots to go away. This is not a multiple choice question, so we do have to check each choice because there might be more than one right answer. So B was 2 root 5, so this is 2 times root 5 times C, which is 5 root 3 times root 15. Now here we've got 2 times 5 is 10. 5 times 3 is 15. 15 times 15 is going to be a perfect square. Root 225. And root 25 is going to be 15. So yeah, this is also going to be rational. A times C is going to be 3 root 5 times 5 root 3, which would be 15 root 15. 15 does not have any perfect square factors, so this one is not going to be rational. We call it irrational. And then we've got A times B times C squared, so that would be 3 root 5 times 2 root 5 times 5 root 3 squared. So 3 times 2 would be 6. Root 5 times root 5 is just 5. Over here we've got 5 squared is 25, and then root 3 squared is 3. So we don't necessarily have to calculate this out. We can see that all the square roots went away already. So we know this one's going to be rational, but just for the sake of being complete here, yeah, we get 2,250. So we got 3 of these expressions that would turn out to be rational, but AC is irrational. That brings us to our last problem here, which is going to be another complex number problem where we're dividing complex numbers. This one's slightly harder than number 21 on the practice test because you've got that square root, you've got that irrational number, but the overall process on how you divide this will be the same. And the trick here is to multiply both the numerator and the denominator by the conjugate of the denominator. So the conjugate of A plus B, write this out. So the conjugate, that is pretty sloppy, but conjugate of A plus B is A minus B. And if we multiply both sides by the complex conjugate of the denominator, that's going to basically get rid of the complex number on the denominator. It's kind of like rationalizing, it's kind of like rationalizing the denominator, where you're trying to get rid of square roots in the denominator, but here we're trying to get rid of an imaginary number in the denominator. You do the same kind of thing, though, where you multiply by the conjugate of whatever that denominator is. So I'm going to multiply by 1 minus I on both the numerator and the denominator here. I am going to have to do a little multiplying, so you can use FOIL or the box method or whatever method you prefer. So I'll just write it like this just to make it a little clearer how the multiplication is going to work out. We'll have to do this for both the numerator and the denominator, and what you're going to find is that denominator is going to simplify nicely. So here we've got root 5 times 1, so that's root 5 times negative I, so that's minus root 5i. Then we got 3i times 1, so plus 3i, and then 3i times negative I is going to be negative 3i squared. We said earlier that I squared was just negative 1. This will end up being plus 3. Okay, with the denominator, we're going to have 1 times 1 is 1, 1 times negative I is minus I, 1 times positive I will be plus I, and then I times I is going to be negative 1, but since it's negative, it'll be positive 1. So let's combine our like terms here and see what's going to happen. We get root 5 minus root 5i plus 3i. So let's clean this up a little bit. We're going to divide each of these by 2, and I'm going to put my real parts on one side and my imaginary parts on another side. So this is going to equal root 5 over 2 plus 3 over 2 minus root 5i plus 3i over 2 as well. So if I want to actually get my answer here, I'm going to combine these and get root 5 plus 3 over 2. That's going to be my real part. That's going to be the a. Okay, that's going to be this part up here. And then here we've got, so I'll say plus, and I'm going to write this. Addition's commutative, so the order doesn't really matter. We're going to put the 3 first. 3 minus root 5 I. Now this question's asking for the b, which is going to be the coefficient to your I. That's this number right here. That's going to be this entire thing right here. We're looking at our answer choices. We're looking for 3 minus root 5 over 2, and that's going to be letter C. That about does it for today. These problems that we're going over are, I just found, a bunch of problems that were online that people had posted that were similar to what they had seen on the test, and also pulled together some problems that some of my students had brought in and be like, hey, how do you work this? I remember there was something kind of like this on the test. So hopefully, after you go through these, you'll have a little bit of a clearer picture of what to expect on the test. Make sure that when you're trying to solve an equation that you just work backwards. It's a lot easier to kind of work backwards from the answer choices and plug in numbers to see if you can get those right. Similarly, if everything is a variable and you don't have numbers to plug in, you can always choose a number to plug in for like A, B, and C and figure out which answer choice works with those. We saw a couple problems like that. Overall, the actual test seems to be, at least from what I'm hearing, a little bit easier than what you see on the practice test. So if you go through those practice test items and you feel pretty good about most of them, minus maybe some of the harder ones, then you're going to do just fine on this test. So that's about it for today. If you guys have any questions or want me to give a little bit more explanation, I know I kind of sped through some of these problems, let me know. I know I tried to get this done in under 90 minutes, and obviously that didn't happen, but I think if you were to work this out without having to explain every problem, I think it's totally doable in under 90 minutes. But yeah, if there's any problems that you want me to go in a little bit more detail, just put your questions down in the comments and I'll try to address those. But other than that, y'all have a great day, and I'll see you next time.